All right. Probably going to be another short one today. As happened yesterday, I was just got lost in screwing around with settings. But I think I'm getting a little bit more established in a workflow. Maybe once the stream recording is published, I'll send a notice out. But right now, I'm just trying to fly a little bit more under the radar, just because I know I'm getting some of the wrinkles out in a bunch of different ways. But first, I think I'll start off with just a review. So yesterday, I started this little toy project. I mean, it's something I've done before, but it's been a while since I just sat down and just did this. I think I mentioned yesterday. The number of times that I am able to just able's not the right word, but I haven't made time for just sitting down and starting a brand new little toy project to play around with for fun. So I'm just doing this to re-inject that kind of fun into like programming effectively. It's really easy to get lost in just like Jira tickets and specs and things like that. Sometimes it's fun to just resimplify things. So I had the idea of doing a longest prefix match implementation. I might use it in something, maybe. I don't know. We'll see. But right now I'm just sort of doing just the sort of simple longest prefix match, like route lookup style kind of thing. The twist that I wanted to add, for no reason other than just that it would be cool to potentially route based on not only longest prefix, but also layer 4 port. So the idea is that every route would come with a series of port ranges, and I just had an idea. But each route would come with a series of port ranges, and the port range must match for that longest prefix in order for it to be considered the selected route. And if not, it will fall back to shorter prefixes until it finds one. And if it doesn't find any, then it doesn't match any. So it's sort of like an interesting longest prefix, but it could be overridden by the port selection. So if the port selection's not there, it will walk back up the tree effectively until it finds one. Now the idea that I just had is what would happen for tiebreakers. It's something I haven't thought about yet. So effectively, what if you have effectively two routes that have the same prefix with the same length, but different port ranges, but it's found in both. I don't know that I have a way of solving that. I suspect the right thing to do would be to mutate. Well, let's handle this in a little bit, because it's this is actually getting into the insertion logic that I was going to actually start writing today, but I'll get to that. To think about, I'm just going to do that section. So what about duplicate routes with different ranges? Likely merge them. That's what I would assume is the right thing to do. We would want to merge them. It would raise the question, why would we be getting that as an input? But given that they want the data indicates that both should match, I think silently merging them is probably the fine thing to do. But we'll deal with that later. What I wanted to do is, well, first of all, I'll get into this here in a little bit, but the code that we wrote thus far, and I actually took the liberty of moving this to a library, which is what I wanted to do in the first place, but I forgot. So instead of just this was just in a bin, like main.rs. But we'll add this into a library, and then we might have some examples where we actually use it. But this will make it really easy for me to structure things and write tests and so on and so forth. Really, all we did last stream is define the types. So we've got route entry, or scrolling back up, we've got the port range, so the port ranges that will store things in. We have an action, which is just sort of like a whether or not, like right now it's just like drop or allow the traffic. Might do something different. So like in sort of like traditional like routing parlance, this might be like a next hop, or maybe allow will be like an enum where you sort of decide how to route it. Like assuming you allow it, assuming it matches something, you need to figure out like what the action is. But I'm just keeping it simple for now. I just want to figure out like should we drop this traffic or allow it. So I'm kind of treating it like an ACL at the moment. The next is route entry, so that uses the action, but it also encodes the port ranges, and so port range is just the high and the low. I forgot to cover that. High and the low port in the range, and of course each route entry is going to have more than one range, and so you have a vec of port range structs. We have our constructor. Then we have we get into the actual tree implementation, the Patricia tree for storing these prefixes. Each node has an optional route entry. Not every node is going to have a route because it might just be a path, like the node just might be a path to a node that does have a route, so not everyone will. And then similarly, not every node has a left or a right, so those are also options. So we'll populate those on insertion. IPv4 prefix, I just added this for now just because I didn't feel like bringing in the IPNet crate, but I still may and probably will do that. There's no sense in reinventing the wheel here. I just did this because I just knew I just needed the address and the prefix length for now, so it was really simple. The tree struct, trie struct, and the implementation, this just brings everything together. So I have a constructor, and then I have a node allocator, which I haven't used yet, but that will actually push nodes onto the vec of nodes on insertion, which I haven't, like I said, I haven't added that yet, but I'll add that here shortly. And then I just added the boilerplate test stuff that Cargo creates. We'll obviously add to that here in a little bit. So what I will do is on my notes, I will begin to add a little bit of a task plan because I think I have that in my very rough private notes and I don't want to keep that there. So we'll say tasks. Oops. We will do define types and basic constructors. That's done. The next we will do is try insertion. There's a lot to talk about there today. I'm hoping to get that done today. I may be running out of time to do that. I gotta start these streams a little earlier. But anyway, we'll do insertion, and then we got to do lookup, and then we'll do port matching, and then we'll do tests. We might do tests along the way. I'm a big believer in testing as you go. And then probably I'd say real world testing. Well, let's actually say like let's split this out into the basic implementation, so stuff we know we want to do, just to make it work the way that we know it should, and then we'll call this extra credit. Oh, benchmarking, real BGP feed, somehow augmented with ports. We'll probably just ingest a real BGP feed and then like synthetically assign port groups. Maybe keep it somewhat realistic. Something like that. Yeah. Yeah, and the other thing to keep in mind here is like this isn't. I mean, when I think LPM, my networking background kicks in, but like realistically, this isn't just something that like a router would use, right? Like you certainly could use this to literally route IP packets accordingly. You know, it's not something like every typical enterprise might want, but you know, some larger shops might have a use case for this. But I would imagine the best reason to have something like this is if you wanted to have is if you had a set of services internally that handled traffic differently, like proxies specifically that handled traffic differently based on the application. And you might have overlapping IP space, and so you want to be able to say like, hey, I have this like really broad range of prefixes that most, if not all, of my applications sit on top of. But I have maybe a portion of a smaller prefix dedicated to this particular application, and then maybe that prefix might actually be shared with a second application, but then another application sitting outside of that entirely. So I think this would be useful for like, you know, systems that have or environments that have applications kind of all over the place, and you need to be able to map, say, like a particular set of prefixes that might overlap, but then including the actual port in that, so you can route accordingly. And like the proxy that you select based on that might be totally different, and it might have a totally different implementation. So this, I think, would get into, like, right now action is just drop and allow, but you might want to do something really, really specific here. So I won't go into too much detail on that, but there might be some things that you want to do on that. So yeah, so having a library that allows you to effectively do kind of like application aware LPM, something like that. I'll just add a quick note on that because I think it's worth calling out. The use case here is a bit niche and possibly contrived, but it's done under the idea, or the idea is it could be useful to have application aware LPM. Especially in cases where applications are distributed across a wide variety of prefixes, messy IP space, we'll call it. Yeah, you could sort of make action a little bit more extensible, right? You could say like, hey, you tell me what you want, like have an action be like a closure of some kind. Like there's all kinds of things you could do with that. Or even just like a user-defined enum, right? So things you could do with that. All right. So we did the types and basic constructors last stream. Like I said, I keep forgetting. So just some inside baseball here. Like I'm getting used to streaming again. I used to stream for like gaming and things like that, but nothing like programming. And so a lot of this is new for me. And I get up pretty early to try to get on, not just to stream, but just to get some like really important stuff done before the day starts. But there's usually a bunch of things that I need to do just to get ready for the stream. And I like to do that kind of stuff the night before, but I just haven't been. And so I end up doing it in the morning. But it's all good. Anyway, get one of these so my mouth doesn't dry out totally. All right. So the next step is to do the actual insertion. So long story short, I'd love to do that today, and if we can do that, then I can feel good about this stream. The other thing is the last stream ended up being about an hour, which is way more than I thought I had time for, frankly. Certainly more than I thought I was going to be able to do. Which is, you know, I know a lot of other programming streamers go a lot longer, but I think that's fine for me for now. Okay. So I forgot what's next. Try insertion. Okay. So for the insertion, I want to first think about, like, the question is, do I want to think about the port ranges or just the try insertion for now and deal with the port ranges later? Like right now we have the try constructor and it allocates with the capacity we want. I don't have the inserter, so let's just build the method and just see where it goes. So let's do insert, and obviously mutable reference. Let's see. We will want. Let's. Let's assume that we have the prefix, right? Oh, we already do. Sorry, the constructor already passes this, so that's fine. Okay, so prefix, we'll just do prefix. IPv4 prefix. Oops. Prefix IPv4 prefix, and then we want also the port ranges. I'm thinking about where I want to get that from, at least for now. Tell you what, let's leave this out for now. We know we'll want it, but we'll just leave the return type off for now too. Yeah. And then let's populate this now for prefix and prefixes. Self prefix. Oh, that's self. Three. Oh, look at that. Ah, I forgot what I was doing here. Yes. And of course, we'll do this. And we will do try.insert prefix. And then, of course, we need to now return try. Okay, so that's the basics. We will also need to remember add port range to this. Yeah. Oh, you know what? Let's just do that now. No reason not to do that now. So we have the port range struct here. And we're also going to have to probably get a little bit more disciplined. I might do that in the next stream, but a little bit more disciplined about where and how these structs are defined, because I'm going to have to start publishing some of them. Because the idea is that you need to define. Well, I think the argument could be that you need to. The question that I have, and I don't know if I have an answer for this right now, is like, does the try constructor do the actual like parsing from whatever the input format is? Obviously, I think that's like something to consider way later. So, but that's what's going through my mind at the moment. But probably not worth thinking about at the moment. So let's just say prefix and ranges, and we can name it something a little bit more sensible later. So prefix, is IPv4 prefix ranges, port ranges, vec of port ranges. Yep. And then here we can then say this is not a vec of prefixes, but rather a vec of prefix and ranges. And we'll just call this like entries. Fundamental transform. Yeah, like ultimately this is probably going to come from a file or something like that where the actual configuration, right, is going to probably be on a file. And like one of the things that I have on my list for much later is hot reloading from a config file. So you have a config file on disk. You have ostensibly some running binary that's performing these lookups and using this library. And when the config changes, a new trie is constructed, and we'll do some switchover mechanism to make sure that's done safely. But yeah, like ultimately, I think this is going to come from some sort of a config file. So I think this is very temporary. Or if it's not temporary, it will be part of a higher level, like parsing module, perhaps, that then feeds into this. So I would suspect that at the end of this module, where the actual trie implementation exists, won't even be necessarily public, right? You'll have this be buried within like some kind of abstraction that says, I just need you to point me to the file and I'll take care of it. But we'll see. That's I think the fun about this is the thing. Again, I just don't do this very often. Is working on little teeny toy projects like this, where the scope is really well contained. So a lot of times the projects that I work on just have like really crazy scope in terms of like not only the different like parts of even one system, but like many systems that all kind of need to be coordinated in conjunction with each other. And like a lot of the requirements are kind of, like you don't have to necessarily wonder what, say, like the user wants. Like that stuff's pretty obvious. That's kind of the job of like product management. Now, obviously, for really complex features, things get ambiguous. So you as the engineer often have to like distill that down. And I actually do enjoy that. But there's something about doing something sort of contrived on the side like this where, you don't even have any users. So you get to sort of like wonder, like, what is the right thing to do here? And I don't even have like a good idea in mind of like what the use case is. I'm sort of figuring that out as I go along. But that's kind of my point. Like, not having that answered for me, even in an ambiguous way, is just kind of fun. Like just thinking through how this possibly could even be useful. I think it's important to do that every once in a while, because if you don't do that, you sort of don't go through that exercise yourself. It's just it's a part of my brain that isn't often exercised, and it's good to have some variety. All right. And actually, now that I'm paused, one thing I haven't done very good at is like actually looking to see if there are stream comments. Now, I'm not expecting anything because my numbers are nothing, and also I don't advertise these streams, so it's like not a big time. I'm not looking at it and be like, oh man, I have no comments. But every once in a while, I actually do have comments, and I never respond to them. So it's something I want to get in the habit of. Okay. Let's get back to business here. So we've got our prefixes, or rather we have our entries, I should say. Yep, prefix and ranges entries, and then we'll do entry.prefix. Actually, let's just pass the whole thing down into insert, and we'll change the type for that. Yeah. Okay. Great. Yes, exactly. So okay. So now we've got that plumbed through. And what are you doing here? Oh, right. And this should be the same, right? Yeah. Yeah, the node vec should be still the length of the entries, or the length of the yes, the length of the entries, because the entries is still one prefix. So it's the only reason I have this new struct is to ensure that the port ranges are attached to each prefix, but it's still the same math. So I'll just do entries.len. And I didn't add a comment here, but let's do that. Definitely a bit of over provisioning, but good enough for now. Because we're just allocating, capacity for the vec of 2 times the number of prefixes that we have. Because again, like the worst case is that each prefix will allocate 2 nodes, which is definitely not a realistic worst case, because there definitely will. I mean, there would have to be literally every IP would have to be allocated as a /32 effectively. So not super realistic, but certainly if we do expect, if we do expect to have a lot of small prefixes, that might be something to consider actually. Is there a how liberal do we want to be in like the prefix length that we want to incorporate, or to allow, right? Like to allow. That may be worth capturing here, actually. Yeah, extra credit. Didn't I have? I thought I had a future enhancements. Oh, I do. Actually, yeah. So let's actually bring these down here. And yeah, let's say more conservative memory allocation, potentially. Very yeah, which I don't know if normal LPM implementations actually do this, but I do know that just conventionally BGP, or really I guess routers on the internet typically do not permit prefix is longer than a /24 for IPv4. I don't know if there is a similar, I mean, I would assume so, that there is a similar restriction on the v6 side, but I don't know if it's /64 or what. It's actually a good question. But anyway, I don't know if that is then like reflected in LPM implementations. I would expect that it's not. I would expect that LPM kind of just allows you to do whatever, and then the convention of not of filtering out prefixes longer than 24 is just a higher level way of enforcing some safety there, or some sensibility there. Anyway, I just wanted to write that down because I think that's something that we'll definitely want to consider when we get to the very, very end. Like, I'm going to get the basic implementation done, and then we can deal with that later. But this is what I'm saying. Like, if I don't have a plan at first, I have to think through these things, and it's nice to have these like pop into my mind every once in a while. I always love that, especially when you're starting off on any implementation, whether it's a toy project like this or at work. It's sort of the same thing. If you're just working on like maintaining a piece of functionality that already exists, and you're kind of making a smaller change to it, you're not really forced to do that all the time. Whereas if you're building new functionality, I think this is the kind of thing that you think about more often. Oh, interesting. I'm getting some dropped frames in the stream. That's not ideal. I don't know why. CPU's not doing too bad. All right. So, so insert. We have now the single entry that we want to insert. So let's actually do that. I realize I've just been dancing around this, and this is the one thing I wanted to do on this stream. I've just been dancing around it. So let's try to get as much done as we can. I don't know if I have a hard stop or what, but I'll do what I can. So for this, the sort of very first thing we want to do is we want to get at the bits of the address, because that's definitely necessary. So let's say, because we're doing v4 only right now, and the first thing to do is we'll just get the adder bits. We'll call it adder bits. Equals entry dot prefix, and then dot adder, I think, right? Yep. Is it a method? No, it's a field. Dot, octets, yes. So octets, but that gets us, what does that get us? That gets us a slice of U8s. That's not exactly what we want, but I don't think it matters, because I think the next thing to do is, let me do this real quick, and then I'll consolidate the two. I think, yes, because we want a U32 ultimately. That's where we're going to do the bitwise operation. So U32 from, this is the important part. I always want to like highlight this, especially for myself, just because v4 addresses or network addresses are always in big endian, and we need to do that conversion now. But we can do that using the slice that we just had. Yeah. So now we have a U32 that's converted from big endian, but now it's in a U32 in Rust, which is little endian. So that's worth calling out. And then we will say the next thing we want to do is we want to walk the bits from most significant bit, which now that we are little endian is right hand side. If start with the index 0 node for the first bit. If the for each bit determine if right or left, which we'll get to here in a second. Check if right or left has a node. If so, follow it. Increment bit counter. If not, insert. This is just the rough outline of what I want to do. Okay, so we have a bit counter. Use size, I guess. Yeah. Right. And so we do walk bits from MSB. I don't know why I put it down here. Well, yeah, that's fine. I'll re-comment as I will, as I go. So we're walking it from most significant bit, which is again the right-hand side. We will then do for, well, do we, you know, yeah. I wonder. I had some other notes on how I wanted to do this, but I don't know if that's even relevant anymore. Because I think I found some other. Well. No, I don't think so. Yeah. No, probably just using the range is fine. Yeah, that's fine. So we'll say for lost my train of thought. For so we're walking the bit. Start with the index 0 node for the first bit. For each bit, determine if right or left. Yeah, right. Yeah, I think so. Let mute bit counter for I don't know that I actually even need this bit counter outside because we're just doing a range basically. Yeah, I mean, I might have been overcomplicating this at first. So we're doing 0 to 31, and then I think we want to do reverse bits. Oops, nope. We're due. That's fine, yeah. So for you as iSize. Do it. Yeah, I don't know. Oh, of course. Yeah, so 0 to 32, 31, and then this needs to be in parentheses. Okay, so we're going from the 31st down to 0. And then we want to have, we'll just say like is, just for now, like is 1. And here's where we do our little check. So the logic here is we have our IP at our bits, right? We want to shift those left so that we can position the bit that we're looking at in the most significant bit position. So in order to do that, we need to do 31 minus I. So that gets us there. But then we want to actually do an AND against all of this once we've done that against 1. And that should give us effectively a 0 or a 1, which should give us the answer we want. And then of course we just do greater than 0. So if it's 1, we can see that. So that should work. I'm trying to think through. Oh, what now? No implementation for. Did I not? Oh, adder bits is not the right thing to use here. Actually, let's just call this adder, and then I'm going to do what I said I was going to do earlier, which is actually just capture this here. U32 from B bytes. Oops. Man. We'll just call this adder. Okay. So mute, yeah, and then yeah, the bit counter is not needed. I don't know what I was thinking there. So we have our is1. I'm just trying to think through the math here. So we start at the 31st index, so to speak. And we're then so let's say we're looking at the rightmost bit. This will shift it left nothing. So then we'll have just the adder left over. We'll then AND it against all but 1s, and so that'll give us the same thing. So that'll check the rightmost bit. Now again, the rightmost bit, I think I'm still so accustomed to actually thinking in big endian, but the rightmost bit is actually it is the most significant bit because it's little endian. So that's the actual like first decision on the tree. So that's desired. It's just still weird to think of it. Like I said, I think I still think like when I see binary representation, it's always big endian. Just so used to that. Okay, so I think that should be fine. That gets us whether or not this particular bit is a 1. So that means if it is, and actually let's just simplify this here. Now you know what, I don't like that. I don't mind having the extra declaration. It'll be optimized anyway. This gives me some readability. I don't want to do a match though. That's stupid. Is1. Oops. Yeah. There we go. All right. Don't want that either. Is1. Oh, well. Lost where I was going. So if it is, then we want to see if is1, that means we want to then see if self dot, or nope, self dot. Oh no, we did want the other counter wasn't for the bit counter, it was for the node counter. We do want that. Okay, fine. Let mute node counter equals 0. And then we do current. It's actually current node. It's not a counter. That's what we want. Current node. If cur node equals dot right dot is sum, then we want to follow it probably. Yeah, if it's sum, we want to follow it, and we want to the bit counter will just get incremented naturally by doing a continue, which we'll do here in a second. But the other thing we do want to do is update cur node. Which means we probably don't want to do this. We probably just want to do if let sum I idx equals cur node dot right. Nope. Self dot nodes cur node dot right. If it is, then we can say cur node equals idx and continue. And let's do the same thing here. Oops. Left. Yeah, it's basically the same logic. So I may come back and refactor this to be a little more straightforward, but it's nice to see it all. I don't mind duplicate code, especially as I'm building things out. I'm just not the kind of programmer that is able to like think through exactly how I want it to be laid out while I'm building it out. It just depends on what it is. If it's boilerplate, then yeah, it's a little different. But if I'm like actively engaging my like creative thought processes, it's kind of nice to just have all of my brain cycles dedicated to that. So yeah, is one is there, and if it's not, then it goes to left. We then unseat the current node and we continue. The other thing we need to handle is if there is no current node there. In that case, we want to insert. So for that, what we need to do is we want to just thought about something here. I mean, I note this down. Yeah, that's the other break condition. So for that, we say, no, not for that, but going back to what we're currently doing. We are trying to insert the new node that doesn't exist. So that means we want to then call self.alloc node. And for this, we want to actually construct a new node. And I should actually just have a constructor for this, right? Or rather, not even require, honestly, not even require that you pass a node into alloc node. Well, no. We can always fix that later. Where do I define node? Yeah, let's just add a constructor for this, just for simplicity, because otherwise I'm gonna hate all the curly braces around. Oops. And then, oh shoot, right. And then we say, let's handle route option, route entry, but then otherwise let's just return route left none, right none. Because when you're constructing a new node, it's almost always going to be true that you don't actually want to set left or right anyway. And you certainly can set it after the fact, but it's just for convenience sake. It's nice to just not have to worry about that. So that means then I can do node new, and then we say none because we don't even have a route right now. We might. That's the other thing I need to handle. But for now, it's nice to just be able to leave that out. Okay, cool. So then we can then just say, let's do that. Yeah. Great. Oh, you know what? I am going to optimize this a little bit right now because it is very, very redundant at the moment. No, and I actually just lied because I do need to set I do need to set right or left immediately after. But I stand by this at the moment. I'll keep it this naive way for now. Naive isn't the right word, just duplicated, like less clean than I would prefer. But we create the node, and then do we return the index? Yes, we do. We return the index in alloc node, which is good because now we have that, and we can then set. No, I was right. We don't need to set left or right of the newly allocated node. We just need to set the left or right of what is the cur node now. So that means we say self dot nodes cur node dot right equals new node idx. Yep. Oh. Oh, right. It's an option, so we set that. Okay, so nodes. Yeah. Yeah, I think that makes sense. Like I said, I'm gonna come back and clean this up a little bit later. But it's nice to just have this all laid out here for now. Self.nodes cur node dot left equals some new node idx. Yeah. Okay. Yeah, this is all very redundant, obviously. So I think what I'll do instead now is just say let is 1 equals no, let next node equals self dot is equals to if is 1. There we go. Okay, so then I want here why isn't that formatting? Why are you not formatting? Oh, it's because of that. Thank you. Okay, so now, yeah. So then I'll cut this, and then I'll cut this, and then I can make this a little simpler by saying so next node is there. If not, I allocate the node, and then I say next node. Well, actually, yeah. I'll still have to do an is1 check here. That's okay. Just to see where to assign it to. Just the way I have it constructed right now. I could make this a little bit... I could add a method for handling this, but it's fine. I want to move on anyway. So let new node IDX equals that, and then we say like if is 1 else come on. Okay. Okay, so we've got our node inserted. Now, the thought I had here is what I want to deal with. We have an entry where we have the prefix, where I get the adder, and then I think I actually do want to have a counter. Well, I already have a counter. I could just use that. Because what I want to do is at some point I need to check if I need to know when to insert a route effectively. And that would be here. Let route equals if I equals 0. We'll just call that for now. We'll just deal with that here in a second. I just want to plumb the rest through. Oops. And then route. That gives us the route. So let route equals if I equals 0. So what we want to do is check the prefix length. So if I equals, man, I'm just losing my touch this morning. Entry.prefix dot. Wait, what? Thought we had this. P4 prefix. Oh, plen. I just forgot how I assigned that. Plen. Right. So if I equals entry.prefix.plen, now the difference here is we want to do the reverse, so it'll be 32 or 31 minus, right? So if the prefix length is 24, I think that's right. I'll have to check the math here in a little bit, but I think that's right. So 31. We're starting at the 32nd, and we're moving down. So we just need to reverse it. Yeah, right? Am I overthinking this? So it'll go 24. Yeah, it'll go. So for /24, it'll go 24 iterations. So it's literally 31 minus 24. So 7 is where that actually inserts. So it should include 7. So yeah, it should be if I equals 31 minus the actual prefix length. Yeah, okay. I don't know why I was thinking that might be wrong. So in this case, we want to do sum route entry. And here we'll just, again, do something kind of contrived. We'll say action allow. Oops. And then port ranges, we'll just say, oh, we actually have that. So entry.port ranges. And then this needs an else. Oh, yes, yes, yes. Yes, indeed. Where do we... Wait, we haven't used this yet. Oh, well, yeah, of course. That's why. So that's fine. So let's just... we'll clone for now, and we'll revisit it. Oh, yeah. Oh. This is why. Because it's U16, so it totally supports copy, which means we don't need the clone. Or the clone will still just do a copy, but that's fine. For some reason, I was thinking we were referring to entry by reference, which is why that was bulking at us, but that's not true. Oh, really? Does that not invoke copy? We will revisit that. Okay, so we have route, and we are inserting it at the right point. So I think actually that's what we want. I think that's actually pretty good. We'll need to do some validation, but yeah, I think that's pretty good. We might write a test actually. Let's do that. Well, we haven't done the lookup, so we can't really test, I don't think. We can check the node length. Could write a test for that. Yeah, and we also need to handle the port ranges. You need to sorting here first. Yeah, probably up top. We need to sort and ensure that the port ranges don't overlap and all of that. Which means that this probably needs to return an error. That's just, it gets into all kinds of things. I might do a second stream later tonight, just to get ready for that. Okay. Oh, come on. Check let roots equals prefix and ranges. Nope. IPv4 prefix. Man, I just haven't done any of this, any of the nice stuff here. Let's just do that now. And then adder. Oops, I'm losing my mind. I should end the stream soon because that's like I'm obviously not thinking clearly. FN new. And then we'll do IPv4 prefix. Adder plen. Adder plen. And then, did I not do prefix and ranges? No, I did not. FN new prefix IPv4 prefix. And port ranges, port range. This is the kind of thing that I would imagine is not fun to watch on stream, but maybe I'm wrong. Maybe I'll just do all this constructor stuff after the fact. Okay, so prefix and ranges. Prefix and ranges. Prefix ranges. Yeah. Okay. Now we can actually go to our test and say prefix and ranges new. IP, oh, come on. IPv4 prefix adder is, this would be an IPv4 adder from string sure. And then plen is 8. Again, I'm probably going to use the IPNet package. I think it makes a ton of sense. And then what did I get? So I prefix and ranges new, IPv4 prefix, plen 8, and then what am I missing? Argument 2 of type. Oh, and ranges. Port ranges. Port range. High or low, 10,000, high, 2,000. Oh. And then here we will unwrap because it's test. Oh, yep. 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 Stood from, I can't remember. Stud. There's no. Is there really no from string? Yeah. Yeah, I just probably it's probably because I haven't brought it in, but I thought I thought the error message was different there. That's okay. Stood. So let's just import it and see if that fixes it. Stood from sure. Yep. There you go. So here are our routes, and we can always add to that later. Oh man, like this is where it would be really nice to have like a parsing function. Yeah, yeah, for test. Yeah, especially for test. Just to be able to declare my routes in just a big old multi-line string and call it a day. But that's okay. Let's insert. Let's just see what one route looks like, and then that's fine. And then we'll call this 24. I almost want to leave the last octet non-zero to see what happens, but I think it would just. I don't think it would matter, based on our early. The prefix length is what's used. So then, yeah, I think that's our routes. So then we want to do a let tree equals try new, and then we have entries. Well, routes, I guess. And then let's just debug try dot nodes. Just want to see what that looks like. Of course it doesn't. Let's just do that instead. Yeah, these I gotta add derives on a bunch of my stuff. I haven't done that yet. So yeah, okay. Yeah, so if we do cargo test, check tree panicked. Index out of bounds, the len is 0, but the index is 0. Is that because we're not inserting? I bet we're not inserting the first root node. Yeah. Oh, that's what we're doing. We're trying to refer to it first. Yeah. Which would mean that we then need to Huh. I didn't think about that. Because the first bit obviously can be a 0 or 1, so the root node should be kind of like a placeholder almost. Just a way to start. We almost, well, either that or you just don't want to have a root node. You sort of want to almost have two trees. Yeah. No, I think it makes sense to just insert a dummy node. Let root. Well, actually, yeah. So, alloc node. Nodes dot push node new none. I wonder then, the question that I have is, do I need to adjust any of this? And I don't think I do, because all of the these counters are on the address that I'm looking at. So I don't think I need to worry about that. I think I just needed to insert a root node. Yeah, I think that's fine. Let's try to run this again. Yeah, perfect. So, try nodes len 18. Is that expected? 18. I'm not sure, actually. Yeah, why wouldn't it allocate 32 or 24? All right. I have to turn my attention to other things. I didn't get as far as I wanted to today, but that's okay. The next, so I'm gonna look at this a little bit just to see if I did anything wrong, but mostly I'll save things for the next stream. The next thing we need to do is the rest of the insertion logic. The port ranges is the big thing. Like, assuming that the tree is working as expected for like the actual LPM stuff, we need to handle the port ranges. So the port ranges need to be sorted and non-overlapping, and then that will set us up for the lookup, where we can just say, like, just do a binary search on the port ranges to make sure that we find a range that includes the port in question for the lookup. Yeah. Okay. Thank you for watching today, if you are. And yeah, maybe next time I'll try to start a little earlier and do more with the like socializing this. But anyway, until next time, thank you.